Good morning to one and all. Welcome to our favorite video channel Sri Ganit Vignan Sarvasvam. This is B Ramesh Kumar, JL in Mathematics. Now, in this video, we discuss JEE Mains 2020 chapter wise solutions. Now, here we take the chapter sets, relations, and functions. Now, first we discuss the weightage of the chapter in JEE Mains. In last January 2020, there are 6 questions are given from this chapter. Now here 2 questions came from set theory. 2 questions came from set theory and remaining 4 questions came from functions. Now here we observe total 6 questions. In last month 6 sessions held in January 2020. Now here total 6 questions. Each session 1 question coming from this chapter. 2 questions came from set theory. Remaining 4 questions came from functions. Now we discuss these solutions of these questions from this chapter in this class. Now the first question is, let x equals to the set of n belongs to n, 1 less than or equal to n less than or equal to 50. Here the natural number n lies between 1 to 50, and if the set capital A is n belongs to x such that n is multiple of 2. Here the first set n belongs to n, in second set A n belongs to x. Now we take the numbers in the set x. Now here the number is multiple of 2. This is second set. The third set is capital B equals to n belongs to x. Here also the natural number n is multiple of 7. Now here also we take the number in the set capital X, that is multiple of 7. Now these are 2 sets already given. Then we find the number of elements in the smallest subset of x. Then we find number of elements in the smallest subset of x. So if we take any smallest subset of x, that set containing both elements we take from A and B. Now the solution of this problem is, first we observe 3 sets. Here given 3 sets. The first set x is, here we write roster wise the elements we take from which are lies between 1 to 50. Now the elements are 1, 2, 3, 4 up to and so on 50. This is the set x. Similarly, already given 2 sets. Capital A is n belongs to x, n is multiple of 2. Now here we take in this interval 1 to 50, we take the numbers that are multiple of 2. That means here we take the even numbers. So 2, 4, 6, 8 up to 50. So this is the set A. Similarly, we take the set B is, here we take the numbers lies between 1 to 50 that are multiple of 7. Now we take 7 multiples. Here 7, 14, 21, 28 up to last 49. So 7 7 ja 49. So this is set B. Now find the number of elements in the smallest subset of x containing both A and B. Now containing the elements both the sets A and B. Now here first we find number of elements from the set A, number of elements from the set B, and similarly the number of common elements from both the set A and B. Now here we using the formula n of A and B equals to n of A plus n of B minus n of A intersection B. This is our formula. Now here we find number of elements in the smallest subset of x containing both A and B. Now here the smallest subset is A union B. Now find the number of elements in that set. Now using this formula n of A plus n of B minus n of A intersection B. Now here clearly we observe that in the set capital A there are even numbers. Now here multiples of 2 up to 1 to 50, total numbers equals to 25. Here the total numbers in the set A equals to 25, which is clear. Now here total 1 to 50, we take only even numbers. That number of elements in the set is 25. Similarly, we find the number of elements in the set B. Now this is also clear. 7 to 49. So 7 7 is 49. So the total numbers equals to 7. So here the number of elements in the set B equals to 7. Similarly, A intersection B, number of common elements, the multiples of 2 and 7. Multiples of 2 and 7. Here first we find the LCM of 2 and 7. Here 2 and 7 are co-prime numbers. Now the LCM of 2 and 7 is 14. Now we take multiples of 14 from 1 to 50. So multiples of 14 from 1 to 50 are, first one is 14, 14 2 ja, second one is 28, 14 3 ja, third one is 42. So fourth one, 14 4 ja 56. Now which is greater than 50. So here do not take 56. Now we take three numbers in the common set A intersection B. Now here the number of elements in A intersection B equals to 3. So minus 3. Now it can simplify 25 plus 7. That is 32 minus 3 equals to 29. So which is numerical integer type question. Therefore the number of elements in the smallest subset, that is the smallest subset is n of A and B. Now here the number of elements in A and B equals to 29. Now this set contains both A and B. The common elements both A and B equals to the number of elements equals to 29. So this is the solution for the first question. Now the second one is, if A equals to the set X belongs to R such that mod X less than 2, the set B equals to X belongs to R such that mod X minus 2 is greater than or equal to 3, then which of the option is correct answer? Here first find A minus B, B minus A and B, A intersection B. Now find these intervals using the sets A and B. Now we go to the solution. Before going to find these one, first we find the interval of X in the set A, the interval of X in the set B. In set A, here we take mod X less than 2. Now which implies X lies between open interval minus 2 comma plus 2. This is very clear. In set B, mod X minus 2 is greater than or equal to 3. Now which implies X minus 2 is greater than or equal to 3, or X minus 2 is less than or equal to minus 3. Now which implies X is greater than or equals to 5, or X is less than or equals to minus 1. Now the interval is X belongs to minus infinity to closed interval minus 1 union closed 5 open infinity. So this is the interval for X in the set B. First we find A intersection B. Now we take one number line. First we take the number 0, right side values plus 1, plus 2, plus 3 up to and so on. So we take 5 also because of already 5 here. Similarly, in left side minus 1, minus 2, minus 3 up to and so on minus infinity. Now insert the interval A, that is minus 2 to 2. So open. So this is minus 2 to 2. So A equals to open minus 2 comma 2. Similarly, we take the interval in first one minus infinity to minus 1. Minus infinity to minus 1. So this is minus infinity to minus 1 closed. This is open. Here we take 5 to infinity. closed up to plus infinity. Now the common part of this one. Here the common part. So here this is not a common part. This is not a common part. This is not a common part. So this is not a common part. This is not a common part. This is not a common part. Only the common region is this one. Here we take the lower limit is minus 2 to minus 1. Already in B, minus into minus 1. Now here A is minus 2 to plus 2. Now here A lies between open interval minus 2. Now here we take open, and also in B minus 1 including minus 1. In the set minus 2 to 2 already minus 1 including minus 2 to plus 2. Now here we take minus 1 closed. So this is the interval for A intersection B. Now here we observe that the option. Now here we observe A intersection B. My open interval minus 2 minus 1. Already we came the interval open minus 2 closed minus 1. Here open minus 1. So this is wrong. Similarly, we find A union B. Another we take same real line, that is 0, 1, 2 up to 5. Here minus 1, minus 2 and so on minus infinity. Now here minus 2 to plus 2. This is A. Similarly, minus infinity to minus 1. This is B. This is also B. Now total interval. In this one the total interval is here minus infinity to 2 open. Here already in the set A the right value upper value is open to. Now here we take also open to union. Here we take directly closed 5 to infinity, open infinity. Now here we write R minus open to closed 5. R minus open to closed 5. This is A union B. Similarly, we find A minus B. 0, 1, 2 up to 5, minus 1, minus 2 up to minus infinity. Now A is minus 2 to plus 2. Here A, this is. So minus 2 to minus 1, closed interval. This is B. So 5 to infinity. This is B. Now here we observe that to find A minus B. Now the X lies in A, does not lies in B. Now the B interval is minus infinity to minus 1. So here the common part of A and B is minus 2 to minus 1. And similarly the common part does not lies in 5 to infinity. So only A part is minus 1 to 2. Only A. Open minus 1, open 2. So this is A minus B. So A minus B equals to open minus 1, open 2. Now here the option A minus B equals to closed minus 1, open 2. Now we came the interval open minus 1, open 2. Now this is also wrong. Now here A and B also wrong. Now we find B minus A. Here also we take one number line 0, 1, 2 up to 5 infinity, minus 1, minus 2 up to minus infinity. Now here open minus 2 to 2, is A, B is minus infinity to minus 1 closed. This is also B, 5 to infinity closed. Now in this B minus A, now A part is minus 2 to plus 2. Only B, this is minus 2 minus 1 including A. Now here minus infinity to minus 2. Minus infinity to open minus 2. Union 5 to infinity. So this is also only in B. So here this is not taken. So this is rewritten by R minus of open minus 2 closed 5. Open minus 2 closed 5. So here this is closed 5. So the answer is 2. Here we observe A minus B. A minus B means X lies in A, does not lies in B. X is lies in A, does not lies in B. Now here this is does not taken. This is not does not taken. This is A minus B. Here B minus A means R minus of minus 2 comma 5. So here A does not taken. Only in B. B value is minus infinity to minus 2 in left side. Right side value already taken. Close 5 to infinity. So this is the solution for second question. Now the chapter functions, 4 questions are there. Now in this first one is, if g of x equals to x square plus x minus 1 and g circle f of x equals to 4x square minus 10x plus 5, then find the value f of 5 by 4. Now the options are, first one is minus 3 by 2, second one is minus 1 by 2, third one is 1 by 2, fourth one is plus 3 by 2. Now here we take two functions, g of x and g circle f of x. Now here directly we find g circle f of x. Here we write g of f of x, which is already given, 4x square minus 10x plus 5. Now here we will substitute f of x in g of x. Here x square. Now replacing x by f of x whole square plus f of x minus 1. Now that equals to 4x square minus 10x plus 5. Now here we take x equal to 5 by 4, which implies f of 5 by 4 whole square plus f of 5 by 4 minus 1 equals to, here we take x value 5 by 4, 4 into 5 by 4 whole square minus 10 into 5 by 4 plus 5. Now put f of 5 by 4 equals to some t, which implies t square plus t minus 1 equals to, here we observe that 4 into 5 square means 25. 25 4 is 100. So 100 by 4 square 16 minus 10 into 5 50 by 4 plus 5. Now here it can simplify, that equals to, the LCM is 16, 100 minus 4 4 is 16, 4 into 50 200 plus 5. 5 into 16 80, that equals to, here 180 minus 200, that is minus 20 by 16. Here cancelled by 4, 4 4 ja, 4 5 ja, minus 5 by 4. So here t square plus t minus 1 equals to minus 5 by 4. Now here we take t square plus t, here minus 5 by 4 take into LHS side, that is minus 1 plus 5 by 4 equals to 0. Now t square plus t, here minus 4 plus 5 minus 1 plus 1 by 4. Now it can be written as t square plus 2 into t into 1 by 2 plus 1 by 2 whole square equal to 0. Now here it can be written as a plus b whole square, that is t plus 1 by 2 whole square equals to 0, which implies t plus 1 by 2 equals to 0, which implies t equals to minus 1 by 2. Here t means f of 5 by 4. F of 5 by 4 equals to minus 1 by 2. Now the option is 2 is the right answer. So this is the solution for this problem. Now the second one is the inverse of the function f of x equals to 8 power 2x minus 8 power minus 2x by 8 power 2x plus 8 power minus 2x. X belongs to open interval minus 1 comma 1. Here we find inverse of the function. So which is very easiest question. Now this is a IPE type question. In IPE 2 marks this question will be given. Now here first of all we take f of x equals to y. Let f of x equals to y, which implies 8 power 2x minus 8 power minus 2x by 8 power 2x plus 8 power minus 2x. Now here divided by both numerator and denominator with 8 power minus 2x. Now here which is equals to y, 8 power 2x by 8 power minus 2x, that is 8 power 4x minus 1 by 8 power 4x plus 1. Now here divide with 8 power minus 2x, both numerator and denominator. The function is reduced by 8 power 4x minus 1 by 8 power 4x plus 1. Now that equals to y. Now which implies here y equals to f of x. That means x equals to f inverse y. Now here find the value of x. Now here we applying componendo and dividendo method. We apply componendo and dividendo method. Here the process of this method is, here for example a by b equals to x by y. Here a plus b by a minus b, that equals to x plus y by x minus y, or a minus b by a plus b, or x equals to x minus y by x plus y. Now here we take a plus b. Here minus 1 plus 1 cancel, 2 into 8 power 4x by here a minus b, 8 power 4x minus 8 power 4x cancelled, minus 1 minus 2, that equals to, here y means y by 1, so y plus 1 by y minus 1. Now 2 cancel, here 8 power 4x equals to y 1 plus y by, here multiply with minus 1, this is 1 minus y. 8 power 4x equals to 1 plus y by 1 minus y. Here we take logarithm on both sides. That means 4x equals to, here we write log 1 plus y by 1 minus y base 8. Log of 1 plus y by 1 minus y base 8. Now here x means f inverse y. So f inverse y equals to 1 by 4 log 1 plus y by 1 minus y base 8. Now replacing y by x, which implies f inverse x equals to 1 by 4 log 1 plus x by 1 minus x base 8. Now this is the answer. Now we check that the answer in these options. Here 1 by 4 log 1 plus x by 1 minus x base e. Now in our answer base 8. Now it can be rewritten as 1 by 4 log base 8. Here 1 plus x by 1 minus x can be written as e power log 1 plus x by 1 minus x base e. Here 1 plus x by 1 minus x can be rewritten by e power log 1 plus x by 1 minus x base e. Now here we observe log a power b. Here we observe this is the form of log a power b. Now it can be written as log a power b can be written as b log a. Now this is taken to left side in the base form. Now that equals to 1 by 4 log 1 plus x by 1 minus x base e into log e base 8. Now here we write 1 by 4 log e base 8 into log of 1 plus x by 1 minus x base e. Now which is in the option 1 by 4 log e base 8 into log 1 plus x by 1 minus x base e. The second option is the right answer to the given question. So this is the solution for this question. Now the third one is let f from R to R be such that for all x belongs to R, 2 power 1 plus x plus 2 power 1 minus x, f of x and 3 power x plus 3 power minus x are in AP, arithmetic progression. Then the minimum value of f of x. Here find the minimum value of f of x. Given condition, here the terms are in AP. Now we go to the solution. The given condition is 2 power 1 plus x plus 2 power 1 minus x and f of x and 3 power x plus 3 power minus x are in AP. Here we know that A, B, C are in AP if and only if 2b equals to a plus c. This is the relation of arithmetic progression. The relation between the terms is 2b equal to a plus c or b equal to a plus c by 2. Now substitute the values in this formula. Here f of x equals to 2 power 1 plus x plus 2 power 1 minus x plus 3 power x plus 3 power minus x whole by 2. Now it can be written as 2 power 1 plus x plus 2 power 1 minus x by 2 plus 3 power x plus 3 power minus x by 2. Now here we also observe this. This is a plus b by 2. This is also a plus b by 2. Now here we know that formula. Arithmetic mean is always greater than geometric mean. Arithmetic mean is always greater than geometric mean. Arithmetic mean. Now the arithmetic mean of two numbers, suppose a and b, is a plus b by 2 is always greater than or equals to square root ab. Geometric mean of two numbers is square root ab. Arithmetic mean of numbers is a plus b by 2. Now we take this result in this one. Here we write which is always greater than or equals to square root of 2 power 1 plus x into 2 power 1 minus x plus square root of 3 power x into 3 power minus x. Now we write f of x is. Now here it can simplify 2 power 1 plus x into 2 power 1 minus x. Here x will be cancelled. 2 power 1 plus 1, that is 2 square. So f of x is greater than or equals to square root of 2 square plus here 3 power x into 3 power minus x. That means 3 power x minus x equals to 0. 3 power 0. So square root 3 power 0. So which is always greater than or equals to, here this is 2 plus 3 power 0 means 1. Square root 1 is 1. Now greater than or equals to 3. So f of x is always greater than or equals to 3. Here we observe the minimum value of f of x is 3. The minimum value of f of x is equals to 3. So which is in the third option. So third option is the right answer to this question. This is the solution for this question. Now the fourth one is, let f of x, let f from open interval 1, 3 to r be a function defined by f of x equals to x into greatest integer x by x square plus 1, where greatest integer x denotes the greatest integer which is less than or equal to x, then the range of f is. Here find the range of the function. Now the options are already given. Now here first we discuss greatest integer which is less than or equal to x. The definition of greatest integer. Here the greatest integer, generally we take some two values. Suppose n plus 1. Now x lies between n less than x less than n plus 1. Here greatest integer x is always equals to n. Greatest integer x is always equals to n. For example, we take the interval 1 less than x less than 2. Here 2 can be written as 1 plus 1. Therefore, greatest integer of x is equals to 1. Here we take x place in place of x, we take the value x is 1.9 is less than 2, which implies 1.9. Greatest integer of 1.9 equals to 1. Similarly, we take 1 less than, replacing x by some 1.2 is less than 2, which implies greatest integer of 1.2 equals to 1. Similarly, we take the values, suppose 2 less than x less than 3, the greatest integer of x is denoted by the left side value equals to 2. Now here the greatest integer value is always less than or equal to x. If for example we take x equals to some 2.75 is less than 3, which is always less than 3, which implies greatest integer of 2.75 equals to 2. So similarly same process follow in greatest integer of x. This is the definition of greatest integer of x. Now in the problem, the domain of the function is open interval 1 comma 3. Domain of f is 1 comma 3. First we divide this domain to two subintervals, that are 1 to 2, this is open interval, and close 2 to open 3. Close 2 to open 3. So these are two subintervals. Because of here given greatest integer x, now between 1 to 2 greatest integer of x equals to 1. Between 2 to 3 the greatest integer x equals to 2. So here we divide the domain to subintervals. Now we take in first interval in open 1 comma 2, here f of x equals to, in between 1 to 2 the greatest integer x equals to 1. Now here we take x into greatest integer x value 1 by x square plus 1. Now that is x by x square plus 1. Here we find f of 1 and f of 2 in the first subinterval. So f of 1 equals to 1 by 1 square plus 1, that equals to 1 by 2. Now which is some 0.5. F of 2 equals to 2 by 2 square plus 1, that equals to 2 by 5, which equals to some 0.4. Now here range of f equals to 2 by 5 to 1 by 2, open interval. So this is open, range also open. Similarly we take in the interval close to open 3. Here we find f of x equals to x into greatest integer x by x square plus 1. Now here greatest integer x 2 to 3 the value is equals to 2. Now here substitute the value 2, that is 2x by x square plus 1. Now here also find f of 2, that equals to 2 into 2 by 2 square plus 1, that is 4 by 5. Now here 4 by 5 means 0.8. Of 3, f of 3 equals to 2 into 3 by 3 square plus 1. So 6 by 10, that equals to, it can simplify, divide with 2, 2 3 is 6, 2 5 is 10, 3 by 5. So this is equal to 0.6. Here the range of f equals to, here we observe f of 2 equals 0.8, f of 3 equals 0.6. Now open 0.6 means 3 by 5. Here close 2. Now close 2, the range of 2 is 0.8, that is 4 by 5. Now here we take closed interval. So this is the range. Now in both intervals, total range of given function. Range of, this is in 2 comma 3. This is in 1 comma 2. Range of f equals to, here the range is 2 by 5, 1 by 2 open, union, open 3 by 5, closed 4 by 5. In total interval 1 to 3. So this is the range of the function to the given problem. Now these are 6 questions came from functions in this JEE Mains 2020 last January. Prepare these questions and practice more problems to write JEE Mains. Wish you all the best. So watch complete video and subscribe my channel for more videos. Now here also we will discuss some other topics coming from JEE Mains. Thank you.